So it's based on the idea of Newton's first law, which is the conservation of motion. And it basically says that any object with a constant velocity can keep on going in the same direction until some force stops it. And so rocket launch is the perfect example of this because with no negative momentum, when it's just sitting on the ground, stationary, the only way to make it go upward is to throw something out in the opposite direction. So engineers and scientists have figured out a way to do this using a combustion reaction, which are the flames that you see at the end of a rocket and and it propels it upward.
When a rocket is launched, it faces many variables. One of these variables being the pressure that is exerted from the air density. So inertia and weight from this air density causes the pressure and the stress on the rocket. So this is called max Q, and max Q is when it reaches its max acceleration. And so max Q, if the rocket is able to pass this point, then it will have a successful launch, but if it does not, it will most likely explode. So the equation for max Q is Q is equal to air density times velocity squared.
So now that you guys know what max Q is and how to find it, you can now find the maximum acceleration of a rocket. So given the altitude equation and the down rate equation of the SES bird rocket, find acceleration. So first we need to find the second derivative of each equation, square them, and then add them together, and that will give us our acceleration equation. So now we need to find max acceleration. How do we do that? Find the derivative again. So essentially after finding the third derivative, we have our maximum acceleration equation, which we can then set equal to 0 and solve for t. So for this rocket, our t equals 46.7 seconds. That so happens to be the exact time the rocket reaches maximum acceleration at its point of max Q. So that's how scientists know when they need to slow down the rocket, so they don't build up too much pressure and cause it to explode.
Speaking of explosions, the Challenger in 1986 exploded not because of max Q, but because of its equipment. Because it was so cold that day, the O-rings did not seal properly. O-rings seal the rocket boosters onto the rocket. Rocket boosters are the ones that hold the fuel. Because the O-rings did not attach properly, the fuel leaks out, causing the explosion and costing 7 lives. So the math behind this is basically probability. P equals 0.97. That is the probability that the O-rings will work. Then we have to cube it because there are 3 O-rings, and then we have to square it because there are 2 rocket boosters. You're left with P equals 0.87, which is not of the probability concerning rockets.
That basically means before they even went on the rocket, they knew they had a 13% chance that it would fail and that they would die, but they did it anyways. So now that you know how max Q, Newton's method, and probability go into the launching of a rocket, we have a question for you guys.
So if you guys can answer this question correctly, you're able to launch a rocket. So what is it called when the rocket has the most stress on it or pressure?
I said max.
It's a variable. One letter. It's that. You can read it. First one to read it. Okay. First one to read it. No one's gonna read it.
You say it. You say it. You say it.
Alright, so we're just gonna